Okay. And so we're going to finish up our programming intro first. So I'm going to open up this lab in a new tab. So I have the code here for reference. And so we're just adding this part of the code. And I'm actually started doing this a little bit differently. So I'll update the script so it matches what I write in the example. So we're just going to add this little bit of code to our scene. So I'm going to open up my project folder for MMP 270, go into my game folder and open up project.godot. Still doesn't know that I want the Godot engine for this. I don't really know why I have to do this, but whatever. I'm just going to click OK. And we're back in Godot. And let's go back to my default scene. Okay, so we're still working on our programming. I think I can move my character, but the animation doesn't change. So that's what we have to add in. We can move the player around, but we want the animation to update to reflect the change in state. So, you know, when we hit a button or move or do other things, our animation and other components should reflect that that's what's going on. That's how we communicate to the player that what they're doing is working. And so last time we kind of left off here with the update movement function. And remember, we're capturing the user input. We're looking for these different inputs: move right, move left, move down, move up. And then we're modifying the velocity of the player, or how much we move the player, by the speed variable, which we can change in our editor. And then we use the move and slide to actually move the player around. And so this is where we're going to change a little bit from what is in the original script that I wrote. So originally I just set the animation as part of the player update. And that's fine. There's nothing really wrong with doing it that way. But because the velocity is actually a global member variable, I realized I can actually reference the velocity anywhere I want to in the script. So I don't necessarily need to have this here. And I can imagine times when I might want to set the player animations, but not have the player moving. Like if the player is dying or getting hit or something like that, I want to stop the player from moving, but I still want the animations to occur. So to do that, we can separate our animations from our player update. I might end up deciding that this was not really necessary, but I think this is a slightly better design for our program. So we can always change it if we don't like it in the future, but let's set that up. So I already put in the update animation function here. And so we're going to create that function now. And another thing that is useful when you're editing code in the Godot editor, as well as a lot of, most programming script editors or environments will let you do this. If you look, it's kind of small, but if you look next to our functions or our if statements, anywhere you have a code block, you'll see there's a little caret or arrow. And if you click on that, it's going to collapse that section of your code. So you'll see it makes like a little ... over here. You can see the line numbers change. So instead of going from 19 to 20, it goes from 19 to 38. And this is a useful way to just kind of make our code a little bit smaller so that we can see what's going on. We don't have a ton of code right now, but it's a useful way to kind of make our code a little bit easier to read. So I'm done with my movement. I know that that works. So I'm going to collapse this and write a new function here. So this is convenient because now I can see everything else in my code, but I can also write some new code down here. So I'm going to start with a new function. And this is another one that we're creating. So remember, when we create our own function, we name it using lowercase letters and underscores for spaces. And we don't use the first underscore. So the first underscore at the beginning is for Godot functions only. So my new function is called update animation. And I don't have an argument for this one. I don't really care about the change in time because I'm not updating the movement. It's not as important for this to be exactly perfect. So I'm just going to call this update animation. And so I'll remove this comment since I have this function now. I won't get my error there. And so now I'm just going to update the animation. And so what I need to do is detect what type of animation my player should have. And so what I need to know basically is if my player is moving or not. And there's one pretty easy way to know that, which is using my velocity value. So what I'm going to do first is just print out the velocity value, and you'll be able to see, this is a good tool to use as a developer. You'll be able to see what that value is as it changes. So I'm just going to start by looking at what that value is. So I'm going to print, and I'm going to say velocity here. And so print is a function that's built into Godot. You can see it's red because it's a built-in function. And it just takes an argument. So in between my parentheses, I just put the thing that I want to print out, which is the velocity. And that's going to show up down here in my output. So I'm going to clear this, and then I'm going to run my scene. And you're going to see in the output, it's kind of small, but you can probably see it. It just says 0, 0. And if I move, you can see it goes to negative 200 or 200. That's the speed of my player. So remember, I'm changing the first value of the velocity, which is the x, with my right and left arrows. And then I'm changing the second value of velocity, which is the y, with my up and down arrows. And so it's actually pretty predictable. It's either going to be 0, or it's going to be 200, or it might be negative 200. So those are really the only values that I'm going to see, at least at this point, before I add in physics and other things like that. So it's a pretty predictable value. And so what I can do is use that value to determine what animation I should be playing. And there's a lot of different ways to do this. I'm going to do it in one way that's pretty simple, but there's other ways to do it using different mathematical formulas. So if we go back to our code, you can see what I'm using here is this thing called velocity.length squared. And that's kind of a confusing thing, that length squared. But what that's actually just going to tell me is how big is the velocity. So remember, the velocity is a vector. And so let me just draw my vector real quick. Hopefully my pen is going to work today. Yes, it is. Okay. Let's change to a brighter color. Oh, now it's broken. Okay, let's try. Okay. I don't know why. Okay, I'm gonna try unplugging, plugging back in. Oh boy. Still having pen issues. Okay, that works. Let's try. Oh, I think I need to restart the program. Sorry, I need to debug this at some point, but I haven't had time yet. So let's restart the Epic pen. Okay. Now can I draw? There we go. All right. Okay, so remember our velocity is a vector. So if we have like our coordinate space and we want our player to move up here, the velocity is the x and the y, the change in x and y. And what we can do, instead of trying to determine, if I'm going right or left or up or down, I can just measure this distance right here using the length squared. So length squared is going to tell me what this distance is on my vector. So that's an easy way to just basically say, is my player moving or not? So let's print that out, and then we'll use it. So if I say velocity.length squared, you can see that's a built-in function for Godot. And this function has its own parentheses. So something you'll see a lot in programming is there's parentheses inside of parentheses. So that can be a little tricky. Like if I don't have this parentheses here, I'm going to get an error because I have to match this parentheses. So whenever you see an open parentheses, there has to be a closed parentheses on the other side. That's something that you'll get used to as you see more code. So now we can see that value. It's a really big value. And so if I'm moving, it doesn't actually matter what direction I'm moving in, but it'll show me that overall value. So let's take that, and we're just going to say if that value is greater than 0, then we know that we're moving. So I'm going to take out my print, and I'll take out this here, and I'll just add in a condition. So I'll say if, so we're asking this question, if my velocity, the movement of my player, is greater than 0, then I know that the player is moving, they're not standing still, and so then I want to play my walk animation. And so we'll have more complicated ways to determine what animations we want to play. But for now, we have a pretty simple player controller. So we really just need to decide if we want to walk or not. So now I want to open the player scene real quick and then go back to the script. So we have this animated sprite. And what we want our code to do is take our animation and change from idle to walk. That's really all we need to do to change the animation. And to do that in our script, there's an easy way in Godot to reference our animated sprite. We can use a $. And what the $sign basically says is anything that's inside of this player node, if we just put a $sign and then add the name, it's going to look for that node inside of our player. And so it can already see that I'm looking for the animated sprite, so I can just hit enter to add that. And then the animated sprite has different methods. So if I put a dot after this, it's going to give me some different options. And you can see there's a ton of different options, but what I'm looking for is I just want to play. So I just want to play the animation. So I'm going to find play, and that's a function. So it's going to give me some parentheses. And so now I need the name of the animation. So this is one place where you have to be careful, because if you put in the wrong name, if it's, you know, lowercase or you spelled wrong or something like that, it's not going to work. So let's click on our animated sprite, and so we can see our walk animation is spelled W-A-L-K with a capital W. And so I have to make sure to put that in correctly. So I need some quotation marks for this string value, and then I just put in walk, and that should be it. And so let's see if that works. Oops. I'm playing my player scene instead of my default scene. Let's go to the default scene. And now, okay, now I'm walking. So we have a couple issues. I don't stop walking, and I only walk in one direction. So we're going to fix those, but at least we've changed the animation. Okay, so let's fix the first issue, is that I don't stop walking. So there's an easy way to do this. So the first part of my condition is if the velocity.length squared is greater than 0, meaning if my player is moving in some direction, then I want to play the walk animation. So with an if statement, if the thing is true, I can run some code, but if it's not true, then I may want to capture that and do something else. And so there's an easy way to do that. I just say else. And so when I say if, I have to ask for a condition. And if that condition is true, I'm going to do the code inside of that condition. But I can also just say else, and if anything else is the case, then I can run some different code. So if I'm moving the player, then I'm going to play the walk animation. If I'm not, I'm going to do the same thing here. I'm going to say animated sprite.play, but what I'm going to do is go back to the idle animation. Okay, so that one is just capital I-D-L-E. Make sure you may want to double check that your spelling is correct, but we can see if that works. Okay, so now I can walk. And now when I stop hitting my key, I stop animating. Okay, so I've solved my first problem. Now I need to change the direction of my player, and I'm almost done. Okay, so let's go to a new line. So now what we want to do is change the direction. I'm going to double check my code for a second. Okay, that looks pretty simple. So the way that we can change the direction of the player. So there's a couple ways you could do it. I'm going to do it in a pretty simple way. So I have this walk animation. You could have a walk right and a walk left animation if you want them to look different. But I can also just flip my sprite. Okay, so if I click on this flip H button here, it's going to turn my sprite around. And so depending on how your sprite is shaped and stuff like that, you may need to move some things around, because you can see my collider changes a little bit if I change the position of the player. So depending on how close it is, maybe I can move my player over like this. So it's a little more symmetrical when I flip it over. But as long as it's close enough to what the collider looks like, it should be okay. And so now I can just flip the sprite instead of changing the animation. So now I'm gonna ask another question, but this time I'm gonna ask about the directionality. So I'm gonna say if velocity.x, so this is the horizontal component of the velocity. So if the velocity.x is greater than 0, that means I'm moving to the right. Because if we think about our coordinate plane, this is x, this is y. X is positive this way and negative this way. So if my vector x is positive, if it's greater than 0, which is the middle here, then I'm going to the right. If it's negative, then I'm going to the left. So if velocity.x is greater than 0, I'm going to say animated sprites. And now I'm going to reference this flip h variable here. So I'm going to say dot flip h, and see it comes up in Godot. And so you can see I can reference anything in the inspector over here in my code. And so if I'm walking to the right, my player is actually facing to the right. So I want my flip h to be false. I don't want to flip the horizontal animation. If your player is facing to the left, then you would want to flip. So you can test this. You may have to flip this back and forth. So then the other direction is if velocity.x is less than 0, then we're going to flip it to the left. So I'll say flip h equals true. Okay, so you might be thinking, why didn't I use else here? Well, if the velocity is actually just 0, that means my player just stopped wherever they are. And so then I actually want to leave the flip h in whatever position it was on, because if I was walking to the right, I want my player to keep facing right. If I was walking to the left, I want my player to keep facing left. So depending on how many animations we add and other things like that, we may need to make something more sophisticated here. But for now, I think this is a pretty straightforward setup. And I played this player scene by mistake again. So let's play the default scene. So now if I walk to the right and then I stop, you can see my player is still facing right. If I walk to the left and then I stop, still facing left. And if I walk up and down, it's not going to change the directionality of my player. So that's pretty straightforward. I think that works out pretty well. I'm going to quickly go over, if you are doing this lab, what you would need to do to submit the lab. Any questions before I do that? Oh, I see there's a chat. Oh, okay, so Wi-Fi problems. All right, that's okay, Christina. I'm recording it, so if you need to review it, I will post it later. But thanks for letting me know that you guys are here. Any other questions before I do the last little bit? All right. Okay, so I'm not going to do the actual code because that's your job for the assignment. Although if you have trouble, let me know. I'm happy to go over it with you. But what you can do is either add in new animations for up and down movement. And so just quickly, so this part you could leave alone. What you would need to do is add something similar to this, but instead of talking about velocity.x, you would need to talk about velocity.y. And so you could add another animation. If you don't have another animation and you just want to show that the code works, you could use flip v. It might look kind of goofy, but at least we'd see that it works. So that's one option that you could do. So the other option that you could do is in our input, we have move right, move left, move down, move up. And remember that that's set in our project settings, input map. Okay, so you'd have to add some different inputs and change the code to reflect that. So actually, it might be a little trickier than I first realized, but I think you could still figure it out. If anybody ends up trying to do this and gets stuck, let me know, we can go over it. But basically what you would have to do to complete the other alternative is add in another player. So if I go here and I add a child node and, if I instance a child scene and add another player, here's my player 2. So what would I need to do to control my player 1 and my player 2 with different keys? That's the other thing that you can try to do. So you can have like a local local multiplayer. So right now, both of my players have the same inputs, but what would I need to do to change the inputs for my second player? And that's basically the second part that you could try. So I'm going to delete this, but if you're interested in doing a local multiplayer game, that would be a good time to practice it. If not, the updating the animation should be pretty easy to try. So if you want to do that lab, that's what you would do. Then you would do some documentation. So for the documentation, you probably need some video since we are using an animation. So I'm just going to demo that real quick again using my Xbox game bar. If you're on a Mac, you could use a screenshot application. So I'm going to do the game bar. I'm just going to hit Command G. You can see some of my screenshots from the Outer Wilds here. So I'm going to go to record and I'm going to turn off the audio. The audio is already off. Okay, so I'm just going to record.
Professor,
Yeah.
we can't see the game bar for some reason.
Oh, really? Okay. So do you see this folder of captures?
Yes.
Okay, sweet. All right, so this is the one that I just did, I think. No, it's not. 224. This is the one I just did. Okay. So I'm going to rename this so I remember. So this is my programming intro documentation. So when you do the capture with the game bar, it's just going to do like a little capture. Anyway, I've got the video now. Hopefully you guys can see that. If I want to post this, I'm just going to go to the Open Lab. I'm going to move this over here and create a new post. And so this is my programming intro. And I'm just going to grab the video and drag it on here. And you know, whichever version you did for the programming intro. So I didn't actually do this, but I'll say I added the up and down animations here. And then we just need to get the category. I'm going to look for programming intro. Okay. And if I want to preview, I can preview real quick. There it is. So once you're done, you can publish and I'll get a notification and then I'll take a look at it. Okay, so I'm going to stop the recording. I'll take it.